Love it. All right. So, welcome back, Cohort A. Fantastic. Hopefully you're feeling good. We are having an interesting week this week. We'll go over the week schedule. We are starting Unit 6. Unit 6 has all about bonding and chemical equations and all that kind of good stuff. So hopefully we're going to feel good with that. Yes. All right, everyone's here today. Nice. All right. So, like I said, we are going to get into Unit 6. If you are new to the class, which we do have some new students, so kind of going through a couple things with you. You should have a packet. Those of you at home should also have this packet. It is a little thick. However, that's okay. It's going to get us all the way through February. So this is into March, okay? So you should have the packet. The other thing that I gave you is called a polyatomic ion sheet. You guys are going to need these starting next week, and you'll need them every single day after that. I personally paper clipped mine to the back of my colored periodic table so that anytime I took it out, I had them both. So you can do whatever you want with that. But starting Monday, you will need this polyatomic ion sheet, okay? So put that to the side. You do want your computers kind of ready. They don't want to be open or anything, but at the end of every lecture, we always do lecture questions, just so you know that's kind of where we're headed with this. Okay. All right, good stuff. Let's talk about this week because this week is not normal because of the PSAT. Who in here will be taking the PSAT tomorrow? Yes. Okay. There are quite a few that I saw that were going to be taking it. So let's take a look here. This is our unit schedule for the rest of the unit. So you'll see this is Cohort A, the last week in January once we figure it out. Then all the way through February, there's actually 3 days off in February, the 12th, the 15th, and the 19th because of parent-teacher conferences. So we're trying to keep that schedule of lectures Monday, Tuesday, live class Wednesday, and so on and so forth, lab Thursday, and then quizzes on Friday. Except for on the 11th and the 18th of next month, your quizzes will have to be moved up a day if we don't have school on the Friday of that week, okay? If you want to know when this unit test is going to be, it's going to be on the 26th of February, okay? So let's talk more. So again, this schedule is always on our homepage, so you should know what's going on every single day. I took all of the periodic table stuff and I put it into a last unit folder here, so if you need any of that stuff, it is still there. I just kind of got it out of our way. We are in week 21 right now, week 21. Okay, so if we take a look, tomorrow is the PSAT. So we're going to kind of not have anything to do tomorrow so that our students that are taking the PSAT can do that. Today we're going to start the unit notes. Tomorrow I would just say finish the worksheet at your own pace because we're supposed to be asynchronous. And then Wednesday is going to be another live class as well. Thursday, you guys in the building, we'll do a lab. Those of you at home on Thursday will be at home working on your review stuff in order to take your quiz this Friday, okay? So tomorrow is kind of an off day because I will be in this room proctoring a test, so I can't be calling you guys live when people are taking a standardized test in my room, okay? Anybody have any questions over this week? Awesome. And then once we go back to next week, then everything goes back to normal, kind of saying Monday and Tuesday lectures, Wednesday practice, Thursday lab, okay, and Friday quiz. All right, so let's get into it. Let's just get into the notes, shall we? So the first thing, you should have this packet put in front of you. These are guided notes, so you should be able to go right along with it. You want your periodic table out because we will write on that. Let's do it. Unit 6 is all about chemical equations and chemical bonds. We're going to start very basic today, and then we're going to go a little further into it on Wednesday. So the idea of a chemical bond is that atoms join together chemically to become stable. Now, at the end of the period, you're going to have 3 lecture questions. So I suggest you go ahead and fill these in and play along because when you're doing your lecture questions, they're always directly from the notes. Okay. Atoms join together chemically to become stable. So you guys can probably, and I'm going to skip down here just a touch. Here are 2 atoms, okay? First off, we have a sodium atom. If you look at your periodic table, what is the atomic number for Na sodium? How many protons does sodium have? Can you see? 11. Perfect. Okay. And if it is an atom, that means it is neutrally charged, correct? If it's an atom, it is neutrally charged. So how many negative electrons must I have as well? Plus, how many do you take away to get to 0? 11. Perfect. Okay. So that's a sodium atom. Over here, I have a fluorine atom. Can you find him on your periodic table? Good, 9 for its protons. And if it's an atom, it's neutrally charged. So how many electrons must he have? 9. Okay, so everybody sees where we're at. And it says atoms will join together chemically to become stable. While both of these are neutral, neither of them are what's considered stable. And we'll talk about how to get stable today. Okay, awesome. A refresher from the last unit. You guys do know that metals, like the sodium we were just talking about, likes to give away electrons to become positive. You know that non-metals, the yellow one, like to take electrons to become negative. That should be a refresher because you had a test on that last week. Good. The only other thing, if you do not have it on your periodic table, if you got a new periodic table, write this right now. 1 valence electron for everybody in group 1, 2 valence electrons for everybody in group 2, 3 valence electrons, 4, 5, 6, 7, and 8 valence electrons. So if you do not have those numbers at the top, make sure you write them up there. We're going to talk about valence electrons again right now. Okay. All right, let's do it. So the first thing that we drew was we drew sodium. How many valence electrons does sodium have? 1 valence electron. Fantastic. And the other one that we have on our paper is fluorine. How many valence electrons does fluorine have? 7. Perfect. So looking at your paper, you see that little guy here is 1 valence electron for for sodium. And then fluorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. Okay, so let's talk about it now. How do we make bonds? We make bonds. Electrons. Circle this in the word. Electrons. That might be on your lecture questions. Electrons are either transferred between atoms. And let's say that Jackson is transferring me some money into my bank account. That means it goes from you to me, right? So the word transferred means somebody gives and somebody takes. Okay? So to make a bond, electrons are either transferred or they are shared. Those are 2 different types of bonds. For this unit, we are going to talk all about transferring. That's going to be an ionic bond. Okay? Shared, we're going to talk about more in the spring. Okay, but that's okay. But just so you know, there's 2 types, ionic and covalent bonding. And when they transfer or share, then they become a new chemical. Just like we talked about in the matter unit, salt that you put on your French fries is made of explosive sodium, if you remember from last unit when we threw it into water, and chlorine that can kill you, right? Salt is made of NaCl. Both of those are deadly. However, you're not afraid to put a little salt on your French fries. It's delicious, right? Because once they join together, they're a new chemical. Okay? All right. So which electrons are we talking about? The only electrons you're allowed to use in bonding are your valence electrons. The only electrons, so while over here, sodium has 11 electrons, he can only use this 1 to bond. And while fluorine has 9 electrons, he can only use these 7 to bond. Okay, only valence electrons are used in bonding. Hint, remember, those are the ones at the highest energy level. Okay, perfect. All right, let's get into to the octet rule, shall we? We're all set up for a bond. Let's do it. In the octet rule, atoms will gain or lose valence electrons to obtain what's called a full, or sometimes you'll hear the word stable, level of electrons. Atoms will gain or lose electrons to gain a full level or a stable level of electrons, with it being the octet rule. Any guesses on how many that is? Like an octopus? 8. Okay. Everybody wants 8 valence electrons. Remember, electrons in the highermost energy level. There's always an exception. But remember, who never had 8 valence electrons over here? Who never had 8 valence electrons? Do you remember in group 8 who didn't have 8? Oopsies. Helium and hydrogen don't care to have 8. They are only filling the first energy level, so they only care to have 2. Okay? 1s is filled with 2. Helium and hydrogen are happy with 2 valence electrons. It's your only exception to the octet rule. Okay? So what that means is going to happen. Let's take a look here. That means that sodium here, does he want 1 valence electron? No, he wants 8. Do you think it would be easier in life to just give 1 away? Or do you think it would be easy to beg from 7 people to get more electrons? It's just going to be easiest to give 1 away. If we take this electron and we get rid of it, okay, now that energy level is gone. Let's see underneath it how many valence electrons sodium would have. If this electron wasn't here, we have 1, 2, 3, 4, 5, 6, 7, and 8 in his outer shell. So is he happy now? Absolutely. So he's going to do that. Now, what fluorine will want to do, fluorine's like, hey, I have 7 and I would like 8. Now I will take that 1 more. Okay. So they're stable when they're full, which means they have 8 valence electrons. Main idea, we're trying to get to 8. Let me show you with an electron configuration what I mean as well. Okay. Hopefully you guys have your periodic table. Hopefully you can easily write the electron configuration. Let's do sodium together, shall we? Electron configuration, we start with 1s has 2, 2s has 2, 2p has 6, and 3s has 1 for sodium's electron configuration. That was from the last unit. Awesome. Fluorine, 1s has 2, 2s has 2, 2p has 5. All righty. Now it says, please circle the valence electrons. Okay. What we're going to circle is the electrons in the highest energy level. So what number is bigger? 1, 2, 2, or 3? What's the biggest number you got there? 3, right? So we're going to circle this. This is the valence electron of sodium. If you don't trust yourself, take a look at your periodic table. Does sodium have 1 valence electron? Did you circle 1 valence electron? You circled it correctly. Okay. Now, in fluorine, if you're circling the valence electrons, we're doing 2s2 and 2p5. Anything that has the highest number. Okay. So sodium has 1. Whoa, talk to me.
Sorry.
Oh, you're okay. Sorry. Sodium has 1 valence electron. And how many does fluorine have? 5 plus 2 is good. 7 valence electrons. Have either one of those fulfilled the octet rule? No. Probably see where we're going to go with this. It's not that tough. But then we're going to turn it into charges, which makes it a little bit harder. So what you're probably going to see, does this sodium want this bad boy? No, he doesn't. He says, get out of here. And if I take away the 3s1. And now you had to circle the valence electrons. That would be my 2 sets of 2. How many does that have now? Is he happy? Oh, yeah. And now fluorine's like, guys, since you're giving them up, since you're giving these electrons away, how's about I take that extra one, and now I'm 2p6 instead. 6 plus 2 gives me how many electrons? Is he happy? Yes. So you transfer electrons. Okay. Now, the only problem is, let's go back up here, that is going to change something called the charge. This is where it starts to get confusing, so hang with me. Once sodium gets rid of an electron, that means instead of 11, I have 10 negatives. Am I still 0 charged if I have plus 10 minus 11? What is my charge now? Plus 10, or plus 11 minus 10. Did I say that backwards? Plus 11 minus 10 gives me a what charge? Positive by 1. Very good. Okay. If fluorine gained an electron, now he has plus 9 minus 10. So his charge is what? Negative by 1. Very good. So as soon as you start transferring electrons, now you're changing charges. But the nice thing about the periodic table is that that trend is directly on the periodic table. Let's write it on there. As you can see on these notes, it says, make sure you have the stable charges for all the A groups written on your periodic table. Let's do it. Your fancy periodic table, the nice one that you've colored, let's write this on there. Everybody in group 1 has 1 valence electron, and they will choose to get rid of that 1 valence electron, just like sodium did. And when sodium gets rid of an electron, it becomes positive by 1. So on your periodic table, everything in group 1 is stable. And you can see I wrote mine in green up here. Everything in group 1 is stable with plus 1 charge. Okay. Everything in group 2, they're going to get rid of 2 electrons. So they're going to be stable with a plus 2 charge. You'll probably see a pattern, and then we're going to flip it. Everything in group 3, in order to get to 8, is it easier to give up 3 or try to gain 5? Let's just get rid of 3, shall we? So everything in group 3 will be stable with a plus 3 charge. Now it gets weird because everything in group 4 has 4 valence electrons. You're halfway to the octet rule. So you would have to know more information for this group. So we'll stay away from it for a little bit. But in group 4, you can either give away 4 or you can gain 4. So above this group, write plus or minus 4. Depending on who they're reacting with, we'll tell you what charge they need. And we'll talk about that next week. Okay. Now, things start getting weird in the nonmetals. Remember here in our picture, if you start gaining electrons, you're no longer positive in charge. What are you charged if you're gaining electrons? You become negative, okay? So let's talk about it on our periodic table. How many more electrons does group 5 need to get to 8? 3 more, correct? So if it gets 3 extra negatives, everything in group 5 is going to be stable with a minus 3 charge. So you can think of it as like a hill. Plus 1, plus 2, plus 3, plus or 4, plus or just minus 3. Everybody in group 6 needs 2 more electrons, so that's going to be negative 2. Everything in group 7, he has 7 valence electrons. In order to get to 8, he only needs 1 more. So I'm talking astatine, iodine, bromine, chlorine, fluorine. All of these are stable with a negative 1 charge. Now, last but not least, how many valence electrons were you supposed to have? The octet rule says you need 8. So does anybody in group 8 want them? Do they want to give them? Do they want anything to do with electrons? No, leave me alone. So what charge do you think that they're going to have? If they don't want to take or give them, they're always going to have a neutral charge. okay? You got to commit that portion to memory, okay? It was a little confusing, but hopefully you guys got it if you just look at it as like the trend as your valence electrons, okay? All right, let's put it together. So bottom line, when the octet is full, the atom is stable. What does octet mean? It means 8, unless you're helium or hydrogen. Can we walk away with that? 8 is what we're looking for. Okay, I'm going to get you guys to draw a few. And draw these out, just like I kind of did. Yep, we're going to the second page now. You got me. Oh, it was that part I just did right there is at the very bottom here. Yeah, right at the very bottom. Perfect. All right, let's get to the practice page. The front is nice. I'm probably going to just do 1 or 2 with you, but then I want you guys kind of going along here. How and why is an atom atomic bond formed? How do you form it? You form it. You form it by giving or taking or sharing electrons. And why are they formed? They got to become stable. Okay. You got it. You might see this on your lecture questions here in just a second. Awesome. I would like to do 2 of these with you because the bigger they are, they get a little bit harder. So let's go ahead and do this. It says, please write the full electron configuration and circle the valence electrons. So we're going to go 1s2 for carbon, 2s2, 2p2. 1s2, 2s2, 2p2. What is the higher number? 1 or 2? Very easy. 2. So if it asks you to circle the valence electrons, you're circling these bad boys, correct? How many valence electrons does 2 and 2 add up to? 4. If you don't believe if you're right or not, you can always check yourself. Carbon is in group 4. You were right. Okay. Boop. Boop. Now, let's do krypton. It's a little bit harder, and I want to make sure that you know how to do valence electrons if their D block is involved. So I will help and read it along with you if you would like. 1s2 for krypton. 2s2. 2p6. 3s2. 3p6. 4s2. 3d10. And 4p6. So now, circling the valence electrons, what is the highest number that they have? 4. And they have 2 of them, right? You have to circle all the valence electrons. So if you're circling valence electrons in something that has a D block, we circle the 4s2 and the 4p6. Okay? Valence electrons. Got me? So how many is 2 and 6 equal how many valence electrons? 8. Krypton. Let's take a look. Here he is. Is he in group 8? Oh, yeah. And is he stable? He already has his full octet. That's why he's a noble gas. It's all coming together there. Okay? So the front of the worksheet's really simple. And then it's going to ask what are metals, non-metals, all that kind of stuff. Awesome. So let's talk about the back. The back is going to be a little bit harder. I'm going to do a couple examples with you, and then I'm going to let you finish it and do your lecture questions. So I'm almost done here. I will have to say that there's a bit of a typo. So before we get too far in here, yours says sodium plus chlorine, I think here. I want you to change D to lithium plus oxygen. Sodium and chlorine is a little too easy, if you ask me. So for D, if you could just cross off sodium and chlorine and go ahead and put lithium and oxygen for me. Awesome. Yep, and on the back of that next one. Yep. All right. Now, you're going to do what I kind of did on the notes, but you're going to do it yourself. And there is you think it's super easy, but I'm about to throw you a curveball. Let's do it. Potassium. Does anybody know the chemical formula for potassium? Potassium is K, and iodine is I. Perfect. Now I need you to look at the number of valence electrons. It says, please draw what will happen with the valence electrons when the following elements react to satisfy the octet rule. How many valence electrons does potassium have? He's in group 1, so he has, give him 1 valence electron next to himself, shall you? Iodine is in group 7, so how many does he have? 7. 7 E's around him. 2, 3, 4, 5, 6, and 7. Now this one's going to be very easy. I promise it'll get harder. What in the world might you do if potassium doesn't want his 1 and iodine wants how many more? He wants 1. So just circle this electron. When these react, you're going to send an electron here. Now he'll have 8, and he got rid of that one. So he has 8 in his second energy level. But now he says, please tell me the charge the elements will now have. Okay, so you can either use the charges we just wrote up there, or you can mathematically think about it. If I lost a negative electron, I'm going to become positive by 1. So potassium turns into a +1. And if iodine gained a negative electron, he's going to be negative by 1. Okay. Now, a little easy. Let's make it a little harder, shall we? You're waiting for it. Lithium and oxygen. What is the chemical symbol for lithium? Li. And the chemical symbol for oxygen? Oh, beautiful. How many valence electrons does lithium have? 1. Everybody knows because he's in group 1. Feeling it? How many valence electrons does oxygen have? 6. 1, 2, 3, 4, 5, and 6. Interesting. Oxygen has 6, and the octet rule says we want how many? 8, right? How many does lithium have to give? Lithium only has 1 to give. Is this going to be happy? Are we going to be happy here? We're not. What if oxygen didn't react with 1 lithium? What if oxygen reacted with 2 lithiums? Now, could we set up a scenario where everybody could be happy? I think we can. This lithium does not want this electron, so he's going to give it away, and he's become a +1. This lithium also does not want this electron, so he's going to give it away, and he's also going to become a +1. Now, oxygen has 6 of his own, and then he's going to take these 2. Does 6 + 2 make 8? Yeah. Is he happy? Whoop, whoop. But now he is negative by how many electrons did he gain? Wonderful. Okay. See how that kind of works? So we're just getting started. We're putting our toes in the water. This shouldn't be super, super hard. We got to kind of figure it out. Okay. I'm going to do one more with you, and then I'm going to make you do your lecture questions and the rest by yourself. There's a nice, this one's extra hard down. I mean, not extra hard, but it's even harder. Good stuff. Let's do this next one together. Magnesium reacting with iodine. Magnesium is Mg. Iodine is I. How many valence electrons does magnesium have? 2. Very good. 1, 2. Iodine has how many? 7. 2, 3, 4, 5, 6, and 7. All right. Magnesium, unhappy. He doesn't like 2 little valence electrons. He wants to have no valence electrons so we can drop down to a lower energy level that has 8. However, can iodine take 2 valence electrons? Iodine's taking how many? Taking 1. So let's give, I don't know, iodine this one. Iodine's now happy with a -1. Magnesium, is he happy? What should we do? If we add another magnesium, is that going to help anything? No. But if we add another iodine, who has 1, 2, 3, 4, 5, 6, and 7. Now magnesium has to react with 2 iodines, and that guy's going to come down here, give him his electron. He's going to be -1. But what charge would magnesium have to be? He got rid of 2 negatives, so he's going to be positive by, you got it, very good, by 2. Okay, so we have about 10 minutes. What we're going to do is I would like for you guys to finish these last 3 right now on your own. If you are new or if you forget, the answer key, we are in week 21, Monday. The answer key always to my worksheets are in the daily folder. So if you want to check yourself, you can. And I would like for you to open up your Chromebook in the last 10 minutes. And after every lecture in this class, we always have 3 lecture questions. I want you to have out your notes. I want you to get them perfect. You should get a 6 out of 6 on all of them. But go on ahead into your lecture questions and answer those 3 lecture questions, okay? I'm going to bother the people in the classroom first. Then I'm going to come and bother you guys at home. But what I want you guys to do is finish this worksheet, okay? And do your lecture questions.